I doubt we'll get all the way there, but I want you to try going a little faster.
To the flag of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Yo, I saw a line tagged on top of it.
Please do the problem. You know what, and to make it go faster, let's just say there we go. Within 2 class periods yesterday, 7 bags of popcorn were made in my room. I do believe we have a trend. Okay. Remember, solve means find all the missing things. In this case, 2 angles, 1 side. Make sure to write them as exactly as possible. And once you have them as exactly as possible, go and find the secant of A. You have a whimsical smirk on your face.
I'm doing right.
Okay. No doodaloo.
Are we supposed to find out what angle A and B is? Is that what it does?
Yeah. To solve means to find all. Anyone still going? Okay.
Sorry.
Means whatever you tried to type broke math. In particular, our fourth commandment of domain. If you did, then you're typing something goofy. Uh-huh. It's saying you can't do that.
What is it that I can't? Whatever you do.
The arc sine of 5/4 is not possible. So that means you either use the wrong value or the wrong function.
Are you going to? That would mean a lot to you. I can do artificial in one time of my life. And that's that. So I can take advantage of it.
That is very true. Because your metabolism disappears later.
That's what I'm saying.
Once upon a time, 220 and buff. Ate whatever I wanted, 3 plates of spaghetti for dinner, wash it down with a half a gallon of chocolate milk, no problem. Never gained a pound. Use it while you got it. Why do you think I sell Pop-Tarts? I'm trying to get kids addicted to useless carbs so that when you get older, then your metabolism slows down, then you get fatter, so then when you come back for like a 10-year reunion or something, you're bigger than me and I can laugh at you. It makes me feel better about myself.
Wow.
Yes. Yes. I'm playing the long game. All right. Oh no, high school reunions are trash. It's just the 10-year reunion is everyone trying to outdo each other. It's just a big urinating match. The 20-year reunion, people start to figure some stuff out, but then you have to deal with the people who peaked in high school still trying to act like it. After that, no one cares until you're all coming back for like a 50-year reunion because half your class is dead. And then it's like, dude, I remember you. Wasn't life good? So, stage 1 is to find your missing side, and you do it by Pythagorean. And did you get got? This is not a 3, 4, 5 triangle, just because those two happen to reduce down to a 3 and a 4. Look at their position. A 3, 4, 5 triangle has 3 and 4 as your side lengths, 5 as your hypotenuse. If I take 64 minus 36, ruh-roh, that's not 25. Okay, square root of 20, what? 28, right? 28, yeah. So 4 root of 7. I thought you said 20, and I was like, whoa, wait, I mathed wrong. Okay, so I do Pythagorean to get my missing side. To get my angles, 2 square root of 7. Right? Yeah, 2 square root of 7. So measure of angle B. From B, I have a 6 and an 8, which is adjacent and hypotenuse. I will do the arc cosine of 6/8 or 3/4. Either one, it's good. For A, it'll be the arc sine of 3/4 or 6/8. And then secant from A, okay, secant is what over what?
Is adjacent over hypotenuse. Offset over hypotenuse.
There you go. Hypotenuse over adjacent. And I can't just leave it as 8 over 2 square root of 7, even though that reduces. I have to rationalize it. 4 root of 7 over 7. So, did you have the correct trig function and value for each of those? Did you get your correct side length? Based off of that length, did you have the correct setup for secant? And then did you rationalize it like you were supposed to? Hi.
for the secant, I just did 8/6, so I did hypotenuse over.
Well, you're wrong.
So, yeah. So should I take out 2 points or 1?
Did you reduce it to 4/3 at least?
No.
2 points off.
That was kind of a no.
Oops. Anything else? Okay. Then the only thing I had someone ask was just kind of how to set up the word problem. About you turn left and then you turn right thing.
Yeah, we need to go over that. That was so confusing.
Okay. I don't have it up here, but I remember it enough. It says you're gonna, okay, you are traveling road. It doesn't matter if road is like this or road is like this. It does not matter. If you turn left like this and then right at a 32-degree angle versus if you were traveling the other way, you turned left and then right at a 32-degree angle versus you were traveling north, you went left and then right at a 32-degree angle versus you were traveling south, you went left and then right at a 32-degree angle. Every single one of them is going to have the same basic triangle of 32 degrees here. What was it, 0.8 here? And then what else did they want to know? It was like the length of that crossroad? Okay. So the fuzzy part about the problem was they never really told us that the wording of the problem was poor because you have to understand that you're hitting the original road because it said it's a detour. If it's a detour, I will do this and then I will do this and then I'm back on the road. Which means you have to assume that since you first turned left, that's a right angle. And then it's just, well, sine, cosine, or tangent. I have from this angle, adjacent and hypotenuse, cosine. So the cosine of 32 is adjacent over hypotenuse. Swap your extremes. Getting whatever thing. So what, cosine of 32 going to be real close to cosine of 30, which is a half. So 1.6 miles, ballpark. Hi.
So I used tangent and I checked my answer on the solutions and they used tangent too.
Oh, were they asking for this instead?
Yeah, they had 32.
Well, okay, it depends how you draw it.
It was worded really weird.
So turn left, 0.8. Depends on the wording. Did they say it intersects this road or the main road? That's the question, I guess. Okay, that's the question. How is it worded? Intersects main road or turn at a 32-degree angle? Intersects the main road. Okay, so then the 32 is here. So it was a very poorly worded question. Because it says detour, you have to understand you're coming back and hitting the main road. It says intersect the main road. okay, that's where my 32 is going to be. So, oh well, their problem sucked. Shouldn't chose something else.
So then it would be tangent.
So if I'm from here, well, what are they wanting to know? Are they wanting to know the length of the crossroad or how far you would have traveled on the main road?
I think how far did it travel?
Determine the length of Elwood Avenue that is detailed.
So then it's that one. Yep. Maybe I should have read the problem instead of trying to go off of memory. Memory not good right now. So in that case, yes, it's tangent. So.
I got 1.28 miles.
Oh wait, not that. Not that.
What is that?
What is what thing in corner? I said that it's a cutoff of whatever story problem is there at the.
What is
I don't know. Kind of looks like a dude jumping. Oh. So people are willing to look at their book for that, but not when I ask for the problem. Y'all goobers. Okay. So again, we've kind of hit on this point a few times that most of you seem to have had geometry right when we had our shutdown, spring 2020. Most of you. If that was the case, then that means you either A, missed out on stuff, or B, just didn't do stuff that you were supposed to be doing, because I know the majority of our student population just gave up mid-April. To be fair, I wanted to. It was in my job description not to. So, stuff about circles. This is all stuff that you should have gone through. Y'all remember maybe some words like a chord, a secant line, a radius, a diameter, a central angle versus an inscribed angle. Okay? Central angle comes from the center of the circle. The defining characteristics of the angle are the two radii. Radii is plural for radius. Okay? Do you remember basics like circumference is 2 pi r, or technically pi times diameter? But since the diameter is twice the radius, 2 pi r. This stuff goes back to middle school. Okay? I just reviewed these formulas when we did literal equations with algebra half. So it's expected coming in that you know the basics of circles. Do I expect that you know inscribed angles hitting the same arc are congruent? I used to. I don't this year. Okay? So there's a bunch of stuff about circles. I may reference it. If it's something that sounds alien, you need to stop me. Okay? Because again, it was just kind of expected that you did this stuff. In fact, everything that we're going to do today is supposed to be in geometry. And I know that our geometry teachers have not covered it for years. So, here we go. Starting up with basic definition of angles. You have an initial and a terminal side. It's not just, oh, hey, look, here's two sticks hanging out in the middle of nowhere. The pointy part between them is an angle. Like, when we say initial and terminal side, it is defined based off of rotation. Okay? The side it starts at, you rotate away from it. Wherever you end is your terminal side of the angle. Whenever we do angle rotation, our positive angles are always counterclockwise. We always go counterclockwise because it matches up with our circle of degrees. By definition, I hate saying this, it's almost a reflexive definition. 1 degree is 1/360th of a rotation. Like, that's its actual definition. So just a little bit of history on it for you. Why would I go in that direction? Why am I going counterclockwise? What's other things in math you can think of that would say I should go in this order? Ouch. Y'all remember quadrants? Quadrant 1, 2, 3, 4. Where it's positive, positive, negative, positive, negative, negative, positive, negative. Okay? So if I follow that quadrant ordering, I will go counterclockwise to form a circle. Additionally, the reason that we have the number 360, the reason that we have this, you notice that there's a lot of stuff that's kind of divisible by 3 and 4 within there. It was based off of fractions. I can take a circle and I can cut it in fourths. I can cut it in thirds. I can cut it in sixths, in twelfths, because the number 12 has that wonderful characteristic of being able to easily divide into fractions. That's why our clock is broken up that way. Y'all know that the clock, the calendar, a circle's measurements, they're all broken up based off of fractions that were easy to divide a day into. Basically a sundial. Okay? So ancient dudes in togas, and actually Celtic calendar came well before Roman. Ancient dudes in kilts decided, hey, I'm going to just chop this thing up into fractions, and then I'm going to throw some numbers on there. So that's why we have 360 degrees as a circle. What you need to be able to do is, please tell me, you could fill this entire circle out if I gave it to you without numbers. Okay? We should just know if I got a circle, I know from start to finish is 360 degrees. So if I cut it in half, I know that's 180. If I cut that in half, I should know that's 90, and then halfway from 90 to 360, 270. If I cut those in half themselves, I should be at 45 degree increments. So 45, 90, 135, 180, 225, 270, 315. If I instead cut them into thirds, so you got to be careful. Blue line, semicircle. If I cut that into thirds, okay, so I'm going from here to here is a third, here to here is a third, here to here is a third. So I take my 180 divided by 3, and those are 60-degree increments. So now I'm at 45, 60, or sorry, 0, 60, 120, and 180. Keep going by 60-degree increments. 240, 300, 360. If I were to cut those areas in half, so between blue and green, half of that. Between green and green, half of that. Between green and blue, half of that. Now we're at 30-degree increments of 30, 60, 90, 120, 150, 180, 210, 240, 270, 300, 330. It's just chopping up a circle into fractions, into parts. I don't care if you can cut a straight line if you've ever attempted to cut a pizza. Anyone do the homemades, not in the brick, not in the cookie tray, but an actual homemade circle pizza? Or at least a frozen pizza, right? Well, I got to feed 6 people. I need to cut this thing either into 6 monster slices or 12 slices. Can you do it? Okay, most people are okay with just doing things in halves and then quarters and then eighths. If you try to ask them to do it into 6 or 12, they just can't do thirds. You end up with one is super, super skinny and the other ones are monsters, and then people complain. Okay. So, you should be able to list those out. Just, you've been working with that since middle school. You should know those. Okay. If I ever go the other direction, if I go clockwise, now it's a negative angle, and those are things. You can have positive and negative angles. They're just based on which way you're rotating. Before we really get into this, there is a side quest of the DMS system. The last time you probably saw this was in geography. I don't know if they had you do any work with it or not. But degrees, minutes, seconds, at the very least, if you've ever had a GPS app on your phone, you know, it gives your location and coordinates, right? So many degrees north, degrees east, right? Or west. Yeah. The DMS system, extra side quest, is built off of this idea that the Earth itself is broken into what? Latitude and longitude, right? Latitude and longitude, which way is which? Okay, I just had people say both. Which is it? I just had people say both. Someone's got a laptop, someone's got a phone. Settle the argument.
Latitude is like a ladder. So it's horizontal.
Horizontal rungs of a ladder.
Latitude, like,
I thought it was a ladder this way. I was like,
longitude is
Okay.
latitude.
So, whenever you're looking at coordinates on a map, on a globe, it is so many degrees latitude, so many degrees longitude. That's because they literally take the Earth and they split it up into degrees. 360 of these bands around the Earth. 360 of these bands around the Earth. Those are terrible, I know, but you get the idea, right? How many outdoor enthusiasts do we have here? Anyone do topographical maps?
Huh? I don't even know what that is. I like being outside.
Yeah.
The maps that got all the squigglies on them. Okay? So the closer they are together means the more steep the inclination is. And the different lines on them represent different heights. Okay, those maps are usually broken into minute maps. Degrees, minutes, seconds. If a degree map is this box, it is 1 degree by 1 degree. So a minute map is when I take that 1 degree by 1 degree section and I break it up 60 by 60 because there's 60 minutes in an hour, so I'll say there's 60 minutes in a degree.
I was hearing something about minutes of an angle.
Yes. Because I'm taking, okay, people had to figure out how do I geographically represent the Earth. So they used what they knew, which was a clock. Because a clock was something that everyone, particularly sailors, they knew what it was and they could read it. So if I break up my map in terms of a clock, something else that is round, this is more like after they figured out the Earth was round, then I go from degrees to minutes. Minutes is given with a single apostrophe on it, just like feet. And then within each of those minutes, so like a minute map of maybe the Black Hills area trails is literally 1 minute wide by 1 minute tall. It covers that much area. Within that, and now you're starting to get into like surveying, military operations, that kind of stuff. Now they're going to take that and break that out. It started as 1 minute by 1 minute. Now they're going to break that up into 60 by 60. Now they're going to go to seconds, which has a double apostrophe on it, just like inches. Well, take the diameter, or take the circumference of the Earth, divide it by 60 to get your minutes, divide that by 60 to get your seconds. I don't know what the circumference of the Earth is off the top of my head. Google it. Do you know that it's different in terms of latitude and longitude because the Earth isn't actually a sphere, it's an obloid? Like, have you ever seen a slow motion video of someone spinning a basketball? It actually compresses. It compresses lengthwise because centripetal force is forcing the basketball outward. The Earth does the exact same thing because we got that juicy molten core. That's a fluid dynamic moving at the center of our Earth, which actually stretches it out as it rotates. So.
Oh, I didn't learn anything. He was gone. I'm sorry. Totally off topic. I'm just.
Okay. Is what? 101 feet. Okay, there you go. So you can get hyper detailed. Yeah. So degrees, minutes, and seconds is broken down like this. degrees, minutes, seconds. 60 seconds is 1 minute. 60 minutes is 1 degree. Okay? The reason for this is, why we have to do this side quest, is the application of it. If I'm going to learn all this stuff about circles, it's very common to say something like Salt Lake City and Phoenix, Arizona are on the same line of longitude. If Salt Lake City is this many degree minute seconds and Phoenix, Arizona is this many degree minute seconds, and the circumference of the Earth is meh, how far apart are those two? So now you use your arc length formula on them, and if you can switch them over into decimal degrees, then you can actually find what the interior measure of that arc is. I can't do that if I can't go from degree minute seconds over to decimals. Okay? So that's the purpose of the side quest, is you need it to do any of the word problems. So, if I got a decimal, this many degrees, if I want to turn that into the DMS degree minute system, degree minute second system, there we go, then I need to recognize I have 56 whole degrees plus 735 out of what? How many minutes in a degree? 60. I have 735 out of 60 minutes. Well, grab yourself a calculator. What's 735 divided by 60?
That makes no sense.
What was it? So that means I have 12 whole minutes, 0.25. How many seconds are in a minute?
60.
So I do this again. This is 56 degrees plus 12 minutes plus 25 out of 60. That many seconds. I did that backwards. I'm supposed to multiply. Dude, I did. I'm tired. Multiply, not divide. I did it backwards. You take your decimal train, 0.735 times 60.
I would say 735 times 60.
0.735, your decimal train. If there's 60 minutes in a degree, and I have 0.735 of a degree, then take 0.735 times 60.
Let me say that makes no sense.
Yeah, I did it backwards.
44.1.
There we go. So do it again. This is now 56 degrees plus 44 minutes plus I've got that 0.1 of a minute. So I'll take that 0.1 times, there are 60 seconds, and yes. So it's 56 degrees, 44 whole minutes, and then at the very end I've got 6 seconds left over. And we use the 1 and 2 apostrophes on it just like feet and inches because these were made by the same archaic Eurocentric white people.
It just says 0, 1, 2.
That's why.
0, 1, 2.
So, if I'm going to go the other way, it's actually a lot easier. Cool?
It looks like we just divide and go in the middle.
Yep. I have 32 whole degrees. And then I have 5 minutes. So that's 5 out of, this is what I was thinking of. There's 60 minutes in a degree. I have 5 of them. 5 out of the 60. What you got to be careful with is how many seconds in a degree. 3,600, right? Because I go from seconds to minutes and then minutes to degrees. So it's a double 60, or 3,600. And then you just jam it in a calculator. Okay.
32.161.
Which is why we're going to say approximately, not that.
What? I got 091.
That's what I got.
What on earth did I do?
Yeah, but wouldn't the degree still be 32 if you look at A?
5 out of 60 plus 28 out of 3,600.
You put 1,000.
Oh, right.
What?
This is 30. That says 3,000.
Yeah, 3,600. 3,600 is 36 hundredths. And then I don't like that, so I'm going to change that to a decimal.
Yeah.
Okay. 32,091. And because it kept on going and going and going and going and going, I'm going to say 0.091, but it's approximately. Okay? This really is a side quest. Like, it could be, I doubt you would ever see this in a math section of a standardized test. It'd be in a science section, though, because it's an application. So this is one of those just random things that might show up later, and I guarantee you it'll show up in application problems. I guarantee you'll have to go DMS to degrees when you hit trig, because the word problems might involve circumference of the Earth. So it's just one of those things that, hey, I don't know if you've ever seen this. You should have seen it in geography. Yes, literally geography. It is okay to do other subjects within a subject.
Well, we were in COVID during that too.
Okay, can I just say, COVID saved us in world geography. We were supposed to do this huge project, and then we didn't. So I was rather.
Yeah, imagine if we were sophomores and didn't have to do the bio project.
No,
This
this
is
the bio project. I did not buy, but I did not want to do world geography.
Yeah, the bio.
Do the problems, please.
That project wasn't together.
Problems. Do them.
Oh, pay attention. I am multitasking. I'm fantastic. Yes. Yes, keep all in mind.
Oh, also, Paul, this is your one and only warning.
We got that yesterday, I thought.
Whenever someone touches my board, I wipe out your points for that class. So, do the problem, please.
It's okay, guys. I would just put it back up there. Paul, I swear, if your name is erased again. Okay. What if it's like not me? Some kid's like trying to sabotage it.
This is one of those instances where I do believe in communal punishment, because it encourages communal enforcement. The reason we have laws at all is because our social contract has stated these are things that our group needs to get along and survive and prosper. The things that you need to get brownies are to not touch that board. enforce this if you want the food. Especially because we're going to get brownies and goodies out of Andrew and Paul way before me. So
Hold up.
you're only 1 point shy there, Haas.
I'm gonna drag that out as long as I possibly can.
Did you do both problems yet?
No.
Are you taking too long?
Maybe.
Is that a point?
No.
Yes, it is. Yeah. Yes.
Hold up. Back up for a bit here.
I just wanted this to be our homework.
Yeah, it's really.
I don't know.
Great work, Hannah. Well done.
Yeah. The last one I
Thank
did.
you.
Okay. Step one, you take your decimal train, 0.875 times 60 and get 52. So I'll take that 52.5 and say 0.5 times 60. Getting 213 degrees, 52 minutes, 30 seconds. Versus just jam it in a calculator. This many portions of a degree, this many portions of a degree, slam it in the calculator and say it's about how much? 89 point mutter, mutter, mutter? Okay. Okay. What?
If it ends in 5, will it work every time?
Wasn't that rounded?
Yeah, I know, but
So I don't know what you're asking.
never mind. I'll
No,
find out.
it wasn't rounded up.
Okay. All right. So side quest, got that out of the way. That way we can deal with the word problems. Back to the this stuff. Okay. Said a degree, by definition, is 1/360th of a revolution. Like that's it. That's its definition. There's an entirely different way to measure rotation. And it's based on the length of the radius. So that my rotation is always definitive of the size of the circle. So the size of the circle isn't going to really affect things. They go hand in hand. It's called a radian. A radian is okay. So you have he's doing things. Okay. If I said this is the length of the ruler, right? 12 inches. Okay. The amount of rotation that I can get by going one ruler, one radius, how far it goes, that's a radian. A radian says I take this length and I'll go that far this way around the circle. Okay? Think of it like a string attached to it, and you, once I hit the end of that, that is a radian. So instead of breaking it up based on arbitrary number because clocks and sundials and dudes in togas and kilts, instead I'm going to say, if my radius is this big, doesn't matter how big the circle is, a radian is that much travel around the circumference. And turns out that if I kept going, Then there's 2 radians. There's 3 radians. When I hit 180 degrees, how many radians will it take?
3.14 pi.
Pi. Okay. So that is my definition. And I want you to put it like giant letters because this is going to come to us in our word problems. 1 radian, which is rotation, equals 1 radius, which is length. One radian is 1 radius. This is also how we are able to do unit analysis problems to cross the boundary between linear measurement versus angular measurement. For example, has anyone ever gotten different size tires on their vehicle? Have you owned your vehicle long enough to have to get new tires?
Yes.
Okay, or maybe you've heard your parents argue about it. Before my current vehicle, I had a little Colorado, little Zoom Zoom truck, right? Little Zoom Zoom truck comes with little cookie cutter tires. I did not like little cookie cutter tires because I was moving snow with my truck. As soon as I got new tires, the circumference of my tires increases. Your speedometer is a direct unit analysis conversion between the circumference of your tires down to the gears in your axle all the way up to the speedometer. Like, it's a unit analysis problem. So what happens when you change the circumference of your tires is your speedometer is no longer accurate. Because now, 1 revolution of that axle covers more linear distance, right? Because now the circumference is larger. Circumference is the perimeter of that circle. So 1 revolution of the tire is maybe another 4 inches. You can say, well, that's not a big deal. What happens when you think you're going 75 and it turns out you're going 82? Okay, that's like if you put giant hick tires on there. But like, it actually changes the accuracy of your speedometer. Like right now, my truck is exactly 1.5 miles per hour off of the speedometer. I know because of all of those signs they have around there to like, slow down! It's not accurate, okay? But that radian radius stuff, we're going to be able to do some word problems with this. Also, we just said that half a rotation, so let's come over here. We just said half a rotation was pi. So that's exactly what we're going to say. Normally, half a rotation is not 360 degrees, 180 degrees. So I'm going to say pi radians is equal to 180 degrees. That's also going to be my conversion factor to go back and forth between degrees and radians. Okay? Please tell me y'all know how to make a pi.
My mom does.
These pies. Okay? Oh, sad. No actual pies. Oh, yeah, y'all are in first semester, so you don't get Pi Day. And y'all were last year when we didn't do Pi Day. If you want to come back for Pi Day next semester, you can. In the past, so not last year, because unlike 90% of South Dakota, you know, I didn't want to die, we did not have Pi Day. Every year that we have March 14th, 314, my wife makes pies. A lot of pies. She usually does something in the order of 12 to 20 pies, and I just load up the counter, and kids are just wandering in all day long. A couple of years ago, I actually got Mr. Spear to flip me off because of it. It was great because we were doing Pi Day, and all of my former pre-calc students were over there in Trig, and I was like, "Hey, y'all want pie or something?" And they're like, "Yeah, cool." And they're all walking out, and he's behind them like, because then I kind of guilted him into going to Safeway for lunch and getting pie for his afternoon classes. But yes, we do Pi Day 314. I have lots of pie. All of the above. Crustless pumpkin pie, which is the only kind that I can eat. It's my grandma's recipe. She made it specifically for me, who's a texture eater. Apple pie, blueberry pie. She does a couple of cookie pies that are basically just a giant cookie for people who hate pies. She does meringue pies. She does the lemon pies. Like, it's like, yeah, it's a thing. So since we got talking about pie, there's Pi Day. In fact, that's how I remember the shutdown. The 2020 shutdown, the last day of school, was March 13th. And we had our Pi Day that day because the next day was actual Pi Day. And then the following week was supposed to be spring break. And we had planned a 2-day long geekathon in the library for Game Club. We were like doing a t-shirt fundraiser. We were going to have sponsorships from our game store. It was going to be all kinds of stuff. But yeah, it was sad. A cheesecake day. Okay.
Ooh, yes, I agree. Oh God.
Yeah. Hi.
We should just have this.
Who what? I'm out of cherry Pop-Tarts. Oh, I got more up there. Okay, yeah, that was horribly off topic. Back up here. If 180 is a pi, what is one full revolution? 2 pi radians. Here's another note to write to yourself. If you ever see just a number and there's no degrees on there, then you assume that it's in radians. Okay. Denied. So keep it going. I recommend the cinnamon swirl frosted ones. They're kind of like cinnamon rolls. It's a decent substitute. I can't because of fire safety rules. Technically, I'm not even supposed to have those, but because the toaster actually has physical elements that heat up, I can't have it in the room.
What if I bring a toaster in class and then take it out?
So 1/4 of a rotation. Remember, pi is right here. Half a pi. But we write it as pi over 2 radians. So get used to this. We're going to have lots of fractions. It's just there's going to be a pi on the numerator, which is why kids tend to freak out during this chapter, because there's fractions everywhere. And now because there's a pi there, they don't understand fractions anymore. Okay?
So how does 90 degrees equal?
Because 1 pi is half the circle.
I understand.
Okay? So if 1 pi is half the circle, then 1/6 of a rotation is 1/3 of the way over to pi. So what would 30 degrees be? Pi over 6. Okay?
How come people freak out about memorizing minutes? This isn't bad at all.
You'd think so. We should get t-shirts like that. I just want to have T-shirts that say, "This isn't so bad." Sullivan's class. Like, so down at the bottom. Since we know that pi radians, 1 pi radians is 180 degrees, that's going to be my conversion factor. If I want to go from degree to radian, I multiply by pi over 180. Or 180 over pi to go the other way. So this page, this slide right here, this is kind of the, like, this is the holy grail of the definition. This is where you're going to keep coming back if you don't understand how radians work. You keep coming back to this one, okay? So, let's put it into practice. If I have 120 degrees, and I want to turn that into radians, I multiply by pi over 180 degrees. You remember your own old unit analysis problems? Degrees and degrees are canceling. Remember cross-canceling with dimensional analysis? So then I have 120 pi over 180. I need to reduce it. Okay? So I have now turned degrees into radians. If it's a negative, nothing really changes. Your answer is just a negative angle in radians. Same thing by pi over 180. Reduce and get negative pi over 4. If I want to go from radians to degrees, this is the more common one because I'll get kids who just can't wrap their head around radians. So they convert their radians over to degrees, they do the problem in degrees, and then they put it back into radians at the end. It works. I will multiply by 180 degrees over pi radians. Because again, I've got my pi's canceling out. I've got my reduction getting 150 degrees. Same thing with negative angles. Multiply by 180 over pi. Pi's cancel. Reduce where you can. Negative 270 degrees. Okay. So real quick, where is 270 degrees normally? A positive 270 degrees. Straight down. Y'all should know you're like north, east, west, south, west. Okay. West. Okay. So you should know your directions because I just call 270 as south. Okay. So what's a negative 270? North, right? Because if I say regular 270 is like this, then that means, or sorry, positive 270, then negative 270 just goes the other way. And that starts leading to the definition of coterminal angles. Get them? Coterminal just means ends at the same spot.
Oh, shoot, I can't see it out. Three makes that into 60, so that's 240. Over. Yep. Look at that, that's like magic, Rudy.
Okay, so just you all keep taking from the bottom row of calculators. You know, there's a whole top row up there that are fully charged.
Don't tell him about the top row. That's mine.
No, that's mine. You know, they all have numbers on them and they're supposed to go into an assigned spot, right?
Don't we eventually say because like college does.
Because it's not a federal holiday.
School is too busy getting
No. Federal holiday means bank holiday. Everyone is off.
Okay. My mom has it, but she works at 3.
That's why.
I was like,
Y'all good? Okay.
I didn't like that one, but this one.
Okay. To draw the angles, you need to be able to, A, know in what quadrant things are. You need to be able to count by fractions. You need to be able to convert back and forth between them. When we talk about positive and negative coterminal angles, a positive angle goes counterclockwise. A negative angle goes clockwise. Because those two angles met at the same spot, they are called coterminal. Notice they both started in the same spot. Specifically, if you go back to the very first slide, the positive x-axis is called standard position. Okay, meaning we're going to start all of our angles from standard position. We're going to start from positive x-axis at 0 degrees and rotate from there. Okay? Yes, you can. Okay. Example. I will now turn 450 degrees. It's almost like I can do that. No? Oh yeah, that was negative 450. You know what? I'll give that one. That was good. That was good. I'll take that. That was good. That was a negative angle. Yeah. That was a negative 450. Good job, Paul.
whenever someone does this, they're gonna trip like, actually, it wasn't 360. It was a negative 360.
That's a good way to get bricked with a longboard. Okay.
I heard lawnmower.
Longboard.
I thought you said lawnmower.
It depends if you're looking at them from the left or the right. So, a positive angle, like alpha. See, if I want to have a coterminal angle that is also positive, well, I can't just go to that angle, right? I can't just go there, because that's already alpha. So I have to go all the way around the block and try it again.
You know that reminds me of?
Example, if alpha, okay, would you say, what about measure is alpha? It's in quadrant 1. It doesn't look to be halfway through, a little past that. So if I said that alpha was about 60 degrees, then a coterminal angle with it, I would just add 360 on there to get 420 degrees. Okay? That's it. That's how you make coterminal angles, is you're going to add or subtract increments of 360 degrees. Okay? If I want to have a coterminal angle, so let's say, go back to the other one.
That's not that, guys. Sorry.
Where would you say that angle is?
Which one are we?
This one.
It's like at a 45 degree. No.
So where exactly is it?
90. 180 plus 45. 250. 225.
225. So if this is 225 degrees, if I were to take 225 minus 360, coming from here all the way back, isn't that what gets me the negative angle? Okay, so take 225 minus 360 and get negative 135 degrees. I would like you to compare that positioning. Compare this angle compare just the general shape and size of that angle to where the positive 135 is on your circle. Isn't it about 135 degrees? It's just going the other direction. So I can get positive and negative coterminal angles by doing exactly that. That's what it says at the bottom. That in degrees, I'm going to say that all of my coterminal angles are all x's such that x equals alpha, that's infinity, alpha plus 360n, where n is an element of the integers.
Is that a Jesus fish?
That's a Jesus fish, alpha. Okay. If I want to know all coterminal angles, I'm just going to keep adding iterations of 360. Do you see why I have to say where n is an integer? Why do I have to say n is an integer? Why can't I say n is a rational? What's half of 360?
180.
Can I add 180 degrees onto an angle and end up back where I started? Those are multiple iterations of it. I'm saying, can I add part of a 360 and get back where I started?
Yeah.
Can I be looking right here and say, I will add part of 360? Hey, Maddie. It doesn't work, right? I have to add or subtract entire increments of 360, and to make sure that it's whole increments of 360, positive or negative, I use integers. So how do I change that to go to radians? All x's such that my x is alpha plus, what is a full revolution in radians?
2 pi.
2 pi. So I just replace this with 2 pi n. I'm going to add or subtract 2 pi's to turn it into a coterminal angle. because that's a full revolution. Pi, pi, pi. No, okay, my pi. Yeah. So that means we get to draw them. Yay! Yes, we see who's good at drawing or not.
Not me. You have protractors. I do.
Probably. No.
I got one.
Okay. Yo, what quadrant is 45 in? How far? So I'm going to start by doing that. Okay. Remember, we always start. My standard position is positive x-axis. I'll rotate 45 degrees from there, ending halfway through quadrant 1. Now, I want positive and negative coterminal angles with it. If I wanted a negative coterminal angle, I'll say 45 degrees minus 360. To get what? Negative 315. And then I draw it by just from standard position going the opposite direction. Okay? I literally went the other way. It still ends at the same spot. That's why they're coterminal. They ended in the same spot. Okay?
So do you just write? Or how would you label that? Or do you just leave it? Does it?
Like that.
Oh, easy.
Ta-da! And if I want the positive coterminal angle, I'll add 360 instead. Getting to draw that, remember I go to my angle. What the? Oh. That's my angle already. I don't want that angle. I want one that's coterminal with it. I'm going to keep going. I'm going to go past it all the way around the block and try it again. I literally add a circle to my 45. And then I say that's 405 degrees. Okay. Some years might look a little sketchy. They don't have to be perfect. Okay. So, same process, but now we're going to go to radians. Start with your crosshairs, your axes. What is a negative pi over 3? What quadrant am I going to be in?
It's down.
Quadrant 4. I like that. If pi is here, then go 1/3 of the way to pi. Pi over 3, a third of pi. Where you're going to start to run into problems is if you try to do a third of a revolution. A third of the way to pi. No. I'm just making the angle. Chill out. So I do this and I label that's negative pi over 3. If I have a negative pi over 3, to get my coterminal angles, I add a full revolution. A full revolution is 2 pi. Now, kids are freaking out because, fractions. Sweet Jeebus, do you not know how to turn that into common denominators? Y'all, it ain't that hard. 2 pi is 6 pi over 3.
So, negative 5 pi.
Negative pi over 3 plus 6 pi over 3 is 5 pi over 3. So we'll go this way for our positive angle, labeling it as 5 pi over 3. For my negative angle, again, just get your common denominators and say if I go negative 1 pi over 3 and then another 6 pi over 3, I'm now at, go all the way around the block and try it again. Okay, now we see who's got the art skills.
Looks like a snare.
Okay.
My circles are very not.
In fact, if you start your arc here and then you have to widen out to get around numbers, by the end you kind of keep doing the golden ratio. Yeah, it's pretty cool.
After I watched that video, I started counting out the golden ratio on tile vlogs like my hallway.
So,
Like I was just like
draw them.
1 by 1.
Get them, get them, get them, get them.
I was like, Sam was like in class with science. True story.
First, you got to make sure you're putting your angle in the right spot to begin with. You have to be able to put it in the right spot to begin with before you even start your problem. And then just add or subtract 360, add or subtract 2 pi. Get common denominators. Do not fear the fraction. And there she be. They don't have to be perfect. One on the left looks like a snail, one on the right kind of looks like a, I don't know, Digimon egg or something.
What?
Digimon. It was a cartoon and toy and card game series in the 90s, early 2000s. They're rebooting it now. Tomorrow, we... Oh, wait, no, you were a day behind. Okay, so tomorrow we're just going to finish this. We may or may not start talking about 4.3. I don't know. Depends how you do with the word problems. 5 days. You did your quiz on Friday last week, which means you do your quiz on Monday next week. So tomorrow we'll just finish off 4.2, maybe talk about 4.3.